We will discuss the second problem on Laurent series, namely expanding the function 1 by z plus 1 into z minus 2 the whole square, valid in the region 0 less than mod z plus 1 less than 3. The second part is 0 less than mod z minus 2 less than 3, and the third part is mod z minus 2 greater than 3. So now in the first part the expansion is required in terms of z plus 1. So I assume u is equal to z plus 1. From that z will be u minus 1. So g of u will be 1 by, I'll have u, and this will be u minus 3 the whole square. This I can write it as a by u plus b by u minus 3 plus c by u minus 3 the whole square. I have split this into partial fractions using partial fractions. So in this case z plus 1 is u, and this will be u minus 3. Z will be u minus 1 minus 2 minus 3 whole square. So this will be a into u minus 3 the whole square plus bu into u minus 3 plus cu. When I take u is equal to 0, the terms second and third term at the right hand side becomes 0. I'll have 1 is equal to 9a, or a is equal to 1 by 9. When I substitute u is equal to 3, the first two terms in the right hand side of this equation becomes 0. I'll have 3c, or c will be 1 by 3. When I equate the coefficient of u squared, I'll have a plus b is equal to 0. From that b will be minus 1 by 9. So g of u will be 1 by 9u, and b is minus 1 by 9 into u minus 3. C is 1 by 3 plus 1 by 3 into 1 by u minus 3 the whole square. So the expansion required is 0 less than mod z plus 1 less than 3. So I will retain the first term of g of u as such. In the second term, what I will do is I will remove 3, minus 3, and here I have minus into minus will become plus 1 by 27, and this will be 1 minus u by 3 raised to the power minus 1, and this will be minus 1 by plus 1 by 27. When I remove minus 3, I have a square here. Minus 3 whole square will become 9. 9 into 3 will become 27, and this will give you 1 minus u by 3 raised to the power minus 2. So this will be 1 by 9u plus 1 by 27. Expansion of this will give you 1 plus u by 3 plus u squared by 9 plus so on, and this will give you 1 by 27. This will give you 1 plus 2u by 3 plus 3u squared by 9 plus so on. This is valid if modulus of u by 3 less than 1. Okay, again when I write like this, 1 by 1 minus z will be 1 plus x squared plus so on. When I differentiate this, I'll have 1 by 1 minus x the whole square. When I differentiate 1 by 1 minus x, I'll have 1 by 1 minus x the whole square. I have to just differentiate the right hand side, which will give you 1 plus 2x. Next term will be x cube. I will have 3x squared plus so on. This will give you the expansion of 1 minus u raised to the power minus 2. So when I replace u with z plus 1, I have the required expansion. 1 by 9 into z plus 1 plus 1 by 27 into 1 plus z plus 1 by 3 plus z plus 1 whole squared by 9 plus so on. And the next term will be 1 plus 2 into z plus 1 by 3 plus 3 into z plus 1 the whole squared by 9 plus so on. And of course, this is valid in the interval 0 less than mod z plus 1 less than 3. So now what you have to do is, whenever you require an expansion in terms of z plus a, you substitute u is equal to z plus a and try to complete it. Now for the second part, we require the expansion of f of z 1 by z plus 1 into z minus 2 the whole square, valid in the region. So now what is the region that has to be taken for the expansion of f of z? You have valid in 0 less than mod z minus 2 less than 3. So as usual, what we do? You assume u is equal to z minus 2 or z is equal to u plus 2. So f of z will be 1 by u plus 3 into u square. This you can write it as a by u plus b by u square plus c by u plus 3, or 1 will be au into u plus 3 plus b into u plus 3 plus c u square. When I substitute u is equal to 0, the first term and the third term becomes 0. You will have b is equal to 1 by 3. When I substitute u is equal to minus 3, first two terms become 0 and c will be 1 by 9. When I equate the coefficient of u squared, I will have a plus c is equal to 0, which will give you a is equal to minus 1 by 9. So g of u will be minus 1 by 9u plus 1 by 3u squared, and c will be plus 1 by 9 into u plus 3 the whole square. Sorry. Is that right? C will be 1 by u plus 3. That's all. Okay. So now I require the expansion in the interval 0 less than mod z minus 2 less than 3. Okay. So now what I will do is, I will retain the first two terms as such, 1 by 9 plus 1 by 3u squared. I will retain this. Now what I will do is, I will remove this 3 in the third term and I will have 1 plus u by 3 raised to the power minus 1. So this will be minus 1 by 9u plus 1 by 3u square plus 1 by 27 into 1 minus u by 3 plus u squared by 9 minus so on. This is valid if mod u by 3 less than 1, which gives you mod u less than 3. So when I replace u with z minus 2, I get expansion of f of z. So I'll have minus 1 by 9 into z minus 1 plus 1 by 3 into z minus 2 the whole square plus 1 by 27 into 1 minus z minus 2 by 3 plus z minus 2 the whole squared by 9 minus so on, valid if 0 less than mod z minus 2 less than 3. So this completes the second part. Now for the third part, again you require f of expansion of f of z, which is equal to 1 divided by z plus 1 into z minus 2 the whole square, valid in mod z minus 2 greater than 3. Okay. So now what I will do is, I will use the term g of u, which will be minus 1 by 9u plus 1 by 3u square plus 1 by 9 into u plus 3. I will be using this for the third part, because anyhow the expansion that we used in second part is z plus z minus 2. I am going to use the same thing. So in this case, what we get is, I will be writing the same value for g of u, minus 1 by 9u plus 1 by 3u square plus 1 by 9 into u plus 3. Of course here we assume u is equal to z minus 2. So I have taken this from the second part. But here the region of validity is different. In the previous case it was mod z minus 2 less than 3. But whereas in this part it is mod z minus 2 greater than 3. So for that what we do is, I will write 1 by minus 1 by 9u as such, 1 by 3u squared as such, and in this I will remove u as a common factor, and I will have 1 plus 3 by u raised to the power minus 1. So this will give you minus 1 by 9u plus 1 by 3u squared plus 1 by 9u into, when I expand this I will have 1 minus 3 by u plus 9 by u squared minus so on, provided are valid in the region mod 3 by u less than 1, which gives you mod u greater than 3. So when I replace in terms of z minus 2, I will have minus 1 by 9 into z minus 2 plus 1 by 3 into z minus 2 the whole square plus 1 by 9 into z minus 2 into 1 minus 3 by z minus 2 plus so on, valid in the region mod z minus 2 greater than 3. So in this case you have to see the region, validity region, and operate it upon the function f of z. So this gives the Laurents expansion. You can see in the two problems that we have worked out, f of z is the same function. Depending upon the validity, the expansion of f of z varies. With this, we complete the second problem.